Welcome to the BBC's visual effects department, rumoured to be the birthplace of Matilda, Sergeant Bash, Shunt, Dead Metal and Sir Kill-a-Lot. There is no better place on earth to introduce you to the art of building robots. Come with me. This is not a definitive guide to building a robot, but what we can do is take you through the various stages of construction. We can talk to the roboteers themselves and give you some advice on what does and doesn't work. For instance, cornflake packets, notoriously bad robots. Okay, you want to build a robot, what do you have to do? Well, if, like me, you don't know one of a server from another, then don't even think about starting. But if you've already got a half-decent grasp of electronics, engineering and radio control modelling, then you're already on the way to being a roboteer. Anyway, before we go into detail, let's start at the beginning. Well, we all know what robots look like in science fiction films. We've all seen My Mate Crichton, for instance. But in the terms of robot wars, what do we actually mean by a robot?
Well, a robot can be anything. I mean, basically, this is a radio-controlled fighting vehicle specifically built for robot wars. It can be autonomous. It depends what skills you have, what facilities you have to build it.
How long would something like that take to build then?
Well, you can build something like this within a week, but a week to 3 months is about average.
And how much would it cost?
Well, again, if you're very good at scavenging, you go around scrapyards, you can pick up things like this for next to nothing. You could probably build one for £100–150.
Well, yeah, one of them. There's lots of different weights, isn't there? What are the categories?
Well, the ones we mostly use on television are the heavyweights because they look the biggest, they're the best, they crash heavier together. But we actually recognise 4 of them. There's the featherweights, lightweights, middleweights and the heavyweights. Now, you can actually do quite a lot with the featherweights. In fact, here's one we made earlier.
Oh, one we made earlier.
This is Demolisher. Now, Demolisher is the reigning current UK featherweight champion. All it is really is one of these radio-controlled cars.
With a sort of metal skin?
Yep.
How much would it cost to build that then?
50 quid.
50 quid? Not bad. Money well spent. Well, Robot Wars is all about creativity, ingenuity and teamwork. It's not about chopping your fingers off. So put your chainsaw down and listen up.
Very dangerous work, building robots. I've had many close escapes, but good safety goggles, good hearing protection, and we're still here.
Number one thing is to remember all the time safety. On top here, there's a link. I put a steel pin in there to stop that thing firing, because if anybody stood in front of this ram and it went off and hit them, it could be fatal. There's no question about that. It isn't a toy. This is really dangerous. And it's a job sometimes to get people to realise this. When I demonstrate robots in schools and colleges, I don't even run it. I show the video because I won't put it anywhere near children because it's just far too dangerous.
Fail-safe. You must have fail-safe on your robot. It's very simple and it's not very expensive. It's £15 for a fail-safe unit here, and it runs from a micro switch off our CAN mechanism there.
And what it does essentially, really, I mean, the micro switch shuts the whole system down. It's linked up to the speed controllers. It cuts the supply voltage to them and stops the machine clearing off under its own steam, really. As soon as it loses the signal from the transmitter, as soon as that's lost, the machine shuts down completely dead, and then go off and squeeze somebody.
Rules and regulations. Rules and regulations govern every aspect of Robot Wars. Many of them are concerned with health and safety issues. What weapons you can have, what weapons you can't, weight limits and so on. For instance, you might like to arm your robot with a dirty great flamethrower like Sergeant Bash, but for your own safety, you can't. A full set of rules and regulations will be issued to you on joining the Robot Wars Club and completing the necessary application forms. But in case you want to know what you're letting yourself in for, here's a brief summary. All explosives, corrosives, flames and pyrotechnics are prohibited. Untethered projectiles are prohibited. Compressed gas is limited to 1000 psi. Hydraulic fluid is limited to 3000 psi. The following materials and practices are prohibited: radio jamming, electronic weaponry, stun guns, Tesla coils, etc., liquid weaponry, water, glue, expandable foam, etc. Fuel capacity is limited to 8 fluid ounces or 6 minutes operating time. Fuel tanks must be adequately protected against penetration. Robots will be inspected for safety and reliability before being allowed to compete. Tethers, blades, arms, levers, air cylinders and all other mechanical parts and weaponry must be strong and secure. The organisers reserve the right to disqualify any entry at their discretion. And please note, all rules and guidelines are subject to change. Contestants who fail to adhere to rules and guidelines may be subject to disqualification. And please remember, do not start building a robot until you've been officially asked to by us. So now you know the rules. You're ready to build your very own galvanised gladiator. And it goes without saying that you're going to be very careful, aren't you? Yes, you are, missus. But before you start tinkering with the lawnmower, it's time to put pen to paper.
Before we built Razor, we spent many evenings thinking of designs of robots that would destroy some of the robots we'd seen on Series 1. And it stemmed from there. We came up with ideas with angle grinders and this, that and the other, but it wasn't really mass destruction. We wanted something that would really sort of give things a good chewing.
The most important aspect of building a robot has got to be the design. Mortis has taken approximately 3,000 hours in total, 1,000 of which was on the design stage. It's desperately important that everything works right first time when you're in competition.
The first thing we did was build a really rough prototype, and that was made out of a plywood sheet with the motors and wheels fixed on. And because before you can actually start to draw anything, you have to know the parameters of what you want to work to.
The materials we used all the way through, we went out and searched the catalogues for most suppliers for materials that were available and then designed around what was available. So again, we've had to put a lot of thought into the overall design.
It's okay to think, well, you'll draw it from square one, but in my experience of making prototypes, which I actually make for a living, I find that you really must make a real rough mock-up for a start. That's my opinion anyway.
We really redesigned the weapon first and then thought, well, how could we mobilise it?
I think that's the key point, isn't it, really, is that most people tend to think of the robots, when observed, that make them mobile chassis first, and then, if there's enough weight left, stick a weapon on of some description. But the way we worked it was really the weapon was first, and then think about mobilising it in a way. So really, if we'd have thought about it in any other way, Razor couldn't have come about, because it was just too much of a... It had just been too heavy.
Yeah.
Of course, you might have designed a future Robot Wars champion on paper, but a basic understanding of radio control technology is essential if you're going to bring it to life. Now, don't get me wrong, autonomous robots capable of doing their own dirty work are allowed on Robot Wars. But for the moment, let's stick with one of these. Now look, I know these robots are remote controlled, and I've heard everything about transmitters and frequencies and crystals, but talk to me as if I'm an idiot. Treat me as if I'm absolutely ignorant, for the benefit of our viewers at home, of course, and tell me what it all means.
Well, basically, this is the radio transmitter, which transmits a signal to the receiver, which then drives the robot. This runs on 40 megahertz. At the back of it, it has an interchangeable crystal, this thing. Now, when you get your rules and regulations, it does specify in there that you bring spare ones of these so you don't clash with other robot frequencies.
And where can you buy all this stuff?
These are available at most good hobby shops. You can buy them. They range in price from around £100 to £150.
Of course, radio control gear is pretty useless unless you've got something to actually control. And that something is obviously your robot. Now, it's not unusual for robots to end life scattered into 1,000 pieces across the arena floor. But they start out life as two pieces, the body and the chassis. Now, of course, the body protects the robot, but it's what's inside that ultimately counts. So, let's have a peek under the bonnet. Anyone got a mechanic?
Let's start from the beginning. Batteries for power here at the front. They're nice and heavy, so it gives you a nice low centre of gravity. They run through these two devices here, the speed controllers. Now remember those, they're important, we come back to them in a minute. But meanwhile, onto the motors. Two in this particular case, they drive independently each wheel through simple transmission, a couple of gears. Back to those speed controllers. Why have we got them there? Well, motors don't really like being switched on, off rapidly like that. They like to go through a nice smooth transition. And that's where the speed controllers come in. But the snag here is that when during normal running, when your motors are running fine, that's great. The speed controllers will act normally. When you come up against something as heavy as Sergeant Bash or get pushed into the corner by Sir Killalot, the motors stall. When they stall, they start dragging power from the batteries through the speed controllers. The speed controllers get hot. Now, where you bought your radio gear from your local hobby store, you probably saw things like this. These are little speed controllers. Now, they're excellent in their own right, as long as they're running something like a model racing car like this. They're no good for running a robot. Here, size is important. You need something like this.
Yeah, with the choice of speed controllers, really, it's basing it on what power the motors are. So with a car starter motor, you're going to need a huge amount of power. With the Caddy motors, it only requires about, say, 100 amps max. Now, there's a bit of a thing with this. Don't go using the radio-controlled car ones because they're just not up to it.
If you didn't have speed controllers, you just have switches, and your motors would be going flat out, so the thing would only go in a dead straight line. You would be impossible to turn it other than very sharp, probably 90-degree or sharper turns than that. Also, you wouldn't be able to slow down and approach something at a steady speed.
I mean, like I say, they're actually rated to 100 amps. On the continuous is about 50 amps, which is about half of that. The motors actually show 23 amps. So as you can see, it's got 23, 50 and 100 max. So that way we know it's not going to burn out, you know it's going to go. And they still do get hot. These speed controllers still need a fan. There's a little cooling fan there. They definitely need that to keep all the heat out of them. And we've run it without it and they've still got hot. So even though those numbers look good, in the real world, they still are straining.
Right, next we go to propulsion. There are two main methods of propulsion. One, the IC engine, or to the layman, the petrol engine. Two, the electric motor. Both excellent, depends on the type of robot you're going to build. There's hundreds and hundreds of different motors available from different sources. If you go to scrapyards, you can find things like this, which is a motorcycle starter motor. Very, very powerful, extremely difficult to reverse. Best avoided. Same thing comes with this. This is a car starter motor, extremely powerful. Again, you'd need to build a gearbox to make your robot go backwards. This is a marine 12-volt DC motor, very, very useful for driving weapons. This is a starter motor for a model aeroplane. Take the drive off, use it on your robot. Quite good, quite cheap. The most popular at the moment is this one. The fabulous C5 motor. Smooth, inexpensive and very efficient.
This is one of our motors. It's actually the Axe motor. It's a 900 watt compound series wound motor, whatever that means. I don't know anything about electronics. I don't claim to know anything about electronics. It's very heavy. It's also very old. It weighs about 6.5 kilograms, which is at least 2.5 kilograms more than the motors that everybody else seems to be using. But they're also more powerful, so it swings and roundabouts. You gain sometimes, you lose sometimes.
This is the power motor, the drive motor. It's a lovely motor. Why mine has got a lot of power is the fact that I cheat a little bit because this is a 12-volt motor and I run it on 24 volts, but it's pulsed, so it doesn't overheat the motor. It would after, say, 10 minutes or a quarter of an hour, but as the bout's only up to 5 minutes long, it doesn't have time to get hot.
We chose electric motors for this robot as the weapon and the chassis just was so heavy. We had no other option. We could have used hydraulic motors. We could have used petrol or something like that, but we managed to do it with 12-volt motors with 24 volts.
And seeing as the pump motor really was going to generate its power from electric, it might as well tie it all up. Why have two systems? Why have petrol? Why have electric? You're going to have to carry two lots of fuel in that way, aren't we? So we worked out that we run a bit of an unorthodox kind of system where we've got two battery packs, which are, one is all connected up into 24 volts to drive the main transmission, and then coming off of one of those batteries is another 12-volt line which drives the pump. So it's a bit unorthodox, but it seems to work. I mean, it makes out for a massive short circuit somewhere along the line, but it hasn't happened yet.
Assuming you're using electric motors, there's really only two types of batteries available to you. One is NiCads. Now these will be in your radio transmitters and receivers anyway, but they're only really suitable for running the feather and lightweights. If you want to middle and heavy, you need lead acid batteries.
Right, now these are special lead acid batteries. They contain no liquid. The advantage of this is when you bang into things like that, there can be no leakage. They come in various sizes, obviously. From this size, much smaller, much bigger.
We use 6 small 5 amp hour batteries on our robot. We could use a much larger one that we've got over here, which is what most teams seem to use. But the thing about using a big battery like this is a 30 amp hour battery. Our 6 small ones are 5 amp hour, so the output's exactly the same. But we can choose where we put these because they're such small batteries.
This is the type of battery we went for, which is a sealed lead-acid battery that runs golf caddies, trolleys, wheelchairs, all that sort of thing. Be surprised how many amps one of these things will knock out.
The batteries are those red things in there. Now, a bit special, they're aircraft starter batteries. Now, they've got a very, very low internal resistance. That means I can dump a lot of current out there in a hurry. That gives you increased acceleration. They're a bit expensive, but they are the bee's knees.
If you get good batteries, then they're going to give you good capacity. So don't go and do like I did in the first place, which was to go down the tip and try and get these batteries cheap, because the thing, it just isn't worth it, because the capacity has totally gone out of them. You might as well buy them. They're only about sort of 30 quid or something like that, and you're going to get the run time out of them and everything. The thing's going to go definitely for about 8 minutes. It's going to be loads of power, and it's just going to be fine. They're going to charge up. They're not going to get hot. We actually had one the other day that was, it looked fine, but internally it just got really hot and it was rubbish. The machine sort of had about half the capability, didn't it? Yeah, so
Slow.
battery choice is really important.
What about bodywork? What would you recommend?
Although metal may seem the logical choice, in fact there's the old traditional material wood. Now wood does have a lot of advantage actually. It's easier to work, it's easy to cut and saw, probably easier than metal. And in actual fact, if your opponent's got a circular saw, you can actually jam the circular saw with wood, which you wouldn't perhaps with metal. There's another material as well, and this is the ubiquitous fiberglass. There are other similar materials like Kevlar as well. Now, this can be moulded. You use a resin to actually make it into the fixed shape. You can, if you've got a complex design you want to do, an animal or something like that, this is probably the only way you can actually do it, mould into shape.
Okay, so you've got your bodywork, you've got it in shape, you've got it looking how you want. What about the aesthetics? Are you going to paint it? What's best?
Well, as an engineer, if you see a very nicely finished piece of metal, it excites us. But visually effective robots is what we're looking for. They've got to be nicely decorated, attractive, and look really mean.
What? A bit like me, really. So, the chassis is nice and strong, the motor's up and running, it looks beautiful, but what about the cutting edge? What about the weapons?
Well, I suppose we can say there's really 4 different types of weaponry that's used on robots. There's spikes and things that we're going to prod, and they can either be fixed to the robot or they can go on things like pneumatic rams like this. You've got lifting devices, and the idea there, they can ideally get under an opponent and flip them over. You've got pickaxes, which can swing over and impale themselves on the opponent. And of course you've got the rotating devices, circular saws and chainsaws.
Probably the most famous component of Mortis is the axe, which everybody loves to see. It was a very difficult thing to design and build. This is actually our 3rd attempt at making it work right.
When you attack, I can just stick the front down into the ground. That's the lowest point on the machine. It will actually plane the surface off the boards we fight on. And when in that attack mode, I can actually fire this ram by pressing this button. There's a very, very slight delay, but it's really powerful. That's about, I expect about a 50th of what it will go. I daren't unrestrict it, because if it flew up without a load on it, it would destroy itself.
On Razor we have a weapon of mass destruction. It was designed to look good and function. It's got 9 tons of squeezing ability. We can drive in underneath opponents and literally crush them. It's fantastic. It runs on 3000 psi of hydraulic oil and 9 tons out of the ram on a 3-to-1 ratio.
This is an ordinary SodaStream bottle. It powered a very successful robot, the bucket on Behemoth. Simple device. This car starter motor drove a flywheel. Attached to the flywheel, a pickaxe. Very successful kilotron. There are other devices you can use, particularly hydraulics, but complicated, need to be very skilled, best avoided by the amateur. There are other things you can use. Really, the choice is yours.
Well, your weapons are attached, your robot's looking mighty mean, but it's no good having a decent robot unless you've got a decent robot driver. Derek, what makes a good robot driver?
Well, believe it or not, the simplest thing, practice. I mean, people build beautiful robots, but without practice, they don't drive them properly.
I've got a lot of experience on driving radio-controlled cars, racing them around, but these big robots, they respond in a very different way. And if you can, just get out and practice, 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 because these things will turn on the spot, they'll spin, go backwards in no time, and it feels very, very different. So just practice, big time.
The number one tip, as far as I'm concerned, as a workplace where you build a robot, has got to be really comfortable. It wants to be well lit, well heated, radio so you can play some good music, because that's got to compete with a nice warm lounge and a nice fire and a television set. And not only has it got to compete, it's got to win.
One of the major pitfalls on Robot Wars is the weight. You really have to watch the weight as you design your robot. Otherwise you're going to rob certain areas of their capabilities.
Yeah, weigh your components first, otherwise you'll have a box on wheels with a spike screwed on the front.
There's one part of robot building that's more important than anything else, and it can be summed up in one word: planning. Nothing else matters. Plan everything before you commit yourself to spending money, making parts, because you'll find very, very quickly that you can get into a muddle and spend a lot of money that will just go straight down the drain because you won't be using half the parts.
If you want your robot to do well at Robot Wars, design the weapon first.
Have the weapon take precedence over everything else. The weapon is the main thing. That's going to be doing all the business. Then put the drives on it. And if it's really good, you're going to win
The Best Design Award.
Yes.
Well, that's almost all we've got time for. Hopefully this step-by-step guide to building your own metal monster has set you well and truly on the road to becoming a roboteer. But before we go, and in traditional school teacher style, here's a brief summary. No talking at the back. Firstly, join the Robot Wars Club to receive necessary application forms, technical advice, health and safety guidelines, and rules and regulations. Secondly, before you start juggling with chainsaws and welding scrap metal together, give a lot of thought to the type of robot you want to build, talk it through with your teammates, and then design your robot on paper. Next, start collecting the necessary components: radio control gear, batteries, speed controllers, motors, armour and weapons. Use your initiative. Scour scrapyards, salvage materials and generally scavenge. If you want to build a heavyweight robot, don't rely on off-the-shelf components normally used in radio control modelling. Then start building your robot safely and carefully. If you're uncertain about some aspect of designing, constructing and operating a robot, don't even start. And if you're under the age of 18, you must involve a responsible adult. Finally, once your robot is up and running, practice, practice, practice. Driving skills are very often forgotten, but are essential for victory in Robot Wars. So there you have it, an introduction to the noble sport of Robot Wars. If this A to Z of do's and don'ts to building your own mechanised warrior has inspired you, then, hey, why not give it a go? If you're interested in becoming part of one of the world's fastest growing sports, then you must first join the Robot Wars Club. Membership includes a club magazine, badge, video and an application form for entry into the world of competitive robot combat. Complete and return this form and you will also be sent technical advice, rules and regulations. Send a £10 cheque or postal order made payable to the Robot Wars Club to Robot Wars, London W1A 3AR, or you can join the club via our website. Point your browsers towards www.robotwars.co.uk. Remember, building and operating robots can be extremely dangerous and we don't want any accidents, so be extremely careful, and if you're under the age of 18, get the help of a responsible adult. So there you have it. Thanks for watching, and remember, join the club, join the cause, build a robot for Robot Wars. Bye-bye.